In this video, I will be showing examples of equilibrium, pendulums, and conservation of energy in a playground setting. My first example of a pendulum will be a swing. For a swing pendulum, a little more work will have to be done. Because the swing is lifted off the ground, I will have to adjust the height measurement. Here the height is at 0.6 meters and here the height is at 0.8 meters from the ground. I will have to subtract them to get the correct measurement, which ends up being 0.2 meters. The first equation I will be using is GPE equals mgh. I will then insert my measurements into the equation and solve for GPE. The answer comes out to be 121 joules. Next, I will be using KE equals 1/2 mv squared. GPE is equal to KE, so I will be inserting 121 joules into KE and solve for velocity. Now I will divide by 65 on both sides and find the square root of that answer. Which then comes out to be 1.9 meters per second. The next example will be of equilibrium on a swing. The equation for equilibrium will be net force equals mass times acceleration. Since it is a swing, there will be two tension forces minus mass times gravity. Because there is no motion, acceleration equals 0. Therefore, the right side of the equation will cancel out and equal 0. Here I will be inserting measurements into the equation and then solve for mass. Once I have found the mass, which is 65 kilograms, I will insert it into the equation to prove that it is equilibrium. Now I am inserting 65 kilograms into the equation to be sure that it is correct. My last but not least example will be conservation of energy on a slide. For this example, I will be setting GPE equal to KE, which is MGH equal to 1/2 MV squared. And now I will just insert my measurements into the equation and solve for velocity. The square root of 49 ends up to be 7, therefore the velocity is 7 meters per second.